we're moving to the second part of direct variation, and we need to be able to translate in a direct variation today. This is how you will see it in any homework. It looks like this, y equals kx. That k is a constant of variation. It is the exact same thing as y equals mx. Exact same thing. So you need to write that down, that it's the exact same thing as y equals mx. To translate, the first thing you're going to want to do is make sure y is on the left side. Because we always relate things to graphing, slope-intercept form. And then you're going to want to move the x to the right side. And then divide through by what is in front of y. Just like our sound. Add or subtract the x term, divide by the coefficient of y. Okay? All right, so let's translate this first one. Y needs to be by itself, and maybe you want to write that. Y needs to be alone, and then be dramatic about alone. Make it all capitals. Yell at yourself about it. Y has to be alone. It has to be alone in order for it to be in direct variation or slope-intercept form. So is y by itself right now? No. What do I need to do? By 2. So I'm just going to divide by 2. Divide by 2. Y equals 3 halves x. I'm in direct variation form. So it's going to say the constant of variation. Your constant of variation is just your slope. What's my slope? 3 halves. So my constant of variation is 3 halves. Constant of variation is the same thing as slope. The next one, 8x equals 4y. I need to get y on the left, so I'm just going to flip-flop them. So I'm going to write 4y equals 8x. I can do that. Now, y isn't alone, so what do I need to move that's by the y? Divide by 4. Y equals 8 over 4 is 2. 2x. And then you have to be able to identify, and this says identify the constant of variation. I don't know why they just can't say slope. I don't know why either. I'm on the same page as you, but I'm rolling along with their terminology. The constant of variation just means find the slope. What's the slope of this line? 2. Okay, this is direct variation as well, this third example, because 0 disappears, so there really is just x and y involved. So it looks like I need to move my x term, I need to add or subtract the x term, so I'm going to minus 5x. Minus 5x. So I'm adding or subtracting the x term. I'm left with 2y equals negative 5x. Now I'm going to divide by the coefficient of y. Divide by 2. Divide by 2. Y equals negative 5 over 2x. My constant of variation is just that k. Remember, they say k, but k is just the slope, m. So my constant, what is it? What's my constant of variation? Yep, my constant is my slope. My slope is what is in front of the x term, which is negative 5 over 2. If I were to graph that, it would mean I'd go down 5 over 2, down 5 over 2. All right, now we're going to identify graphs that represent direct variation. That means that all you have to do is multiply x by something to get to y. That means that I'm adding 0 to it. When I add 0, the 0 is my y-intercept. So anything that has a direct variation goes through the origin. Remember, you're going to see it. They're going to say y equals kx. K is the same thing as m. Okay. So this first example, A, is this a direct variation? Does this go through the origin? The origin's right here. It doesn't go through. So this is no. It is not direct. Is the next one a direct?
Yes.
Yes. Because it goes through the origin. Is the next one direct? No. It doesn't go through the origin. I would have to add something. And lastly, yes. Because it goes through the origin. Not too shabby. We're doing amazing. All right, now we're bumping it up a little bit more. They're going to want you to find the constant of variation. That means they're going to want you to find the slope given a point. Here are the steps. The first thing you're going to want to do is, first off, remember that it's going to be y equals mx. Always remember that. Y is equal to mx. Pay attention. Okay, the first thing you're going to want to do is identify the x and the y. It always goes back to that y equals mx plus b, that equation. We're going to substitute then the x and y into the equation. Okay. Yeah, I say get y alone. You knew it. And make sure it's in slope-intercept form. Slope-intercept form just means y equals mx. In this case, they like to write y equals kx. All right. I think step 3 is off. I don't think that's right. I'm going to show you the process, and we got to figure out what I did with step 3. I did something wrong. First thing I want to do, and I would highly suggest you start this. I write y equals mx. I know that. Now my y goes with y, and my x goes with x. So the x goes here, the y goes here. Put arrows. Arrows are your friend. So I say 7 equals, let's say 4m. That's an m. This is an m that is missing a spot. Okay, write this down. Nope, because my x is 4. The only thing I don't have is my m. So I get m then equals 7 divided by 4. How did I get that? By dividing by 4. That's how I got it. So now I have my m. So this third step is really get m alone. Get m alone. Your constant. That's my constant of variation. Now I just rewrite it. Y equals my slope times x. Done. So step 3 should be get m alone. Another one. Write y equals mx. Make sure you write it under the points. Put arrows where they're supposed to go. So the 12 goes with the y, the 5 goes with the x. The only thing I don't have is the m. The only thing I don't have is the m. So I just write what I have. 12 equals 5m. Then I divide it by 5. And I get m is equal to 12/5. That's my slope. Now I rewrite it in slope-intercept form. Y is equal to my slope times x. And my constant of variation is 12/5. Okay. First thing I do, y equals mx. Y equals mx. Put an arrow. The y goes with the y. The x goes with the x. Plug in. 6 equals 10m. Step 3 says get m alone. M equals, I would divide by 10. 6 over 10. Simplify that down, 3/5. That's my constant, that's my slope. 4, rewrite in slope-intercept form. Y is equal to my slope times x. The first thing you're going to do, or the next step of this lesson, is we're going to create an equation from a table. We're going to create a direct relationship equation, y equals mx or y equals kx. Same thing. Y equals kx is the same thing as y equals mx. So you want to pick a point. A table is a collection of points. It looks like this, x, y. So if I add x, 1, 2, 3, y, 5, 6, 7, my points are 1, 5, 2, 6, 3, 7. So I just pick one of them. I don't care which one you pick. You're going to get the same answer no matter which point you pick. And then you're going to get y alone. So you have to be confident with the last step before you can accurately apply this step. So we're going to then rewrite in y equals kx, which is the same as y equals mx. Same thing. K is m. All right. So this first table, you know what? Well, you don't want to pick the point 0, 0, because then m could be really anything. Let's pick 10, 4. Okay, so that's our point. We're going to pick our point, 10, 4. So I'm going to go 10, 4 is my point. I want it to be y equals mx. The x goes with the x. The y goes with the y. 4 equals 10m. Divide by 10. 2/5 equals m. Hard to see. I'm going to extend the page here. Okay, and then I would just rewrite it. Y is equal to my slope, or my constant of variation, times x. Y equals 2/5 x. Next one, pick a point that is not 0, 0. And I'm going to show you why I don't choose 0, 0. If I chose 0, 0, don't do this. Don't write it down. So y goes with y, x goes with x.